doing anything, right? So, okay. So, yesterday we were discussing, right? Partitioning, right? So, the moment Spark reads the data, what it will do? What was the first thing it will do? Can anyone let me know? DP, Karthik, or Arun, the moment Spark reads the data, so what it will do?
Fresh repartition.
Sorry,
Repartition.
it
Repartition.
will repartition. Okay, not by default it won't do repartition. It will have some default partition size. How it will decide, there is a big theory, but the moment based on the HDFS, right? We discussed HDFS will divide into blocks. Okay, so based on those blocks, number of blocks, it will create number of partitions. Right, that's what we discussed. So number of partitions. Okay, so what happens next after the partitions are imported into your Spark cluster? What happens next? You three can unmute yourself so that you can be interactive. Hello. Yeah. What it will do after taking this partition? What is the next step it will do? Arun and Deepthi, I'm audible, right?
Yes, sir.
Okay. So the moment the Spark creates the data, it will create partitions. Okay. So what it will do with these partitions? Who will process them? What happens next with these partitions?
Transformation,
Sorry.
transformations like map, a filter, and all.
Okay. So transformations will be done on top of these partitions. Okay.
Yes.
Okay. So in between Spark, right? Spark needs to assign this task, right? So
Yeah,
to whom?
Spark.
Hmm. Yeah. Go on.
Then each executor
Hmm.
processes
First thing, when
partitions.
Spark reads the data, it will create partitions. Okay.
Yes.
Now these partitions will be assigned to each executor. Okay.
Yes, each executor.
Then
Later it's transformations.
transformations will be applied on top of this partition.
Yes.
Okay. But when will transformations happen? We discussed some concept, right? So the transformations will not happen until unless dash is called. What is that?
A
Uh,
map
hmm?
mapping, right? Map to each executor before
Map
going to
to each
transformation.
executor, fine. But transformations will not be executed unless there is a dash. What is that?
Code.
Code is fine. We discussed, right, some lazy evolution kind of thing, right?
Let's say evolution. No transfer data is executed until action
Hmm. Until
is called until action is called a lazy evolution.
Yeah,
yes,
without action,
without
Spark
action, nothing will happen. Now,
information.
the
Hmm.
moment Spark load this data into a cluster, it won't do anything until an action is called. Okay.
Hmm.
So you know few actions, right? Showing is an action, collecting is an action, right? First, take all this. These are small actions which are right, we saw on the previous class, right? So these are the actions. So until an action is called, transformations won't happen. Okay, so for clear. Okay. Can anyone let me know what is RDD? We dedicated two classes for this RDD. So anyone let me know what is RDD? Maybe just go with the simple words, not with the technical terms. Okay, you still need to get used to those technical terms, but yeah, just go with the simple words. What is RDD? Simple.
RDD is a fundamental data structure
Exactly. Yeah, fundamental data structure of a Spark. Fine.
representing an immutable. It's immutable.
Actually, your voice is very low, Karthik.
So, uh, RDD representing immutable also.
RDD represents
Representing an immutable.
immutable. Okay, immutable data. Okay, fine.
Fault tolerant and
Fault
distributed.
tolerant. How it's fault tolerant?
So,
How RDD is fault tolerant? Yeah, but how it became fault tolerant? What did it do to become a
it
fault
is
tolerant?
no exchanges.
No,
I mean, no changes.
no changes. That's what immutable means.
Yeah.
Fault tolerant, right? In case of any fault, any failure, what it will do? RDD.
Automatically,
Hmm. Automatically.
automatically store notes.
No. If in case any one of the partition got failed, what it will do? Will it reconstruct from the will it reconstruct from the failure, or what happens? How it became fault tolerant? Okay, let's go to HFS. Okay, for now, just for time being. In HFS, we mentioned HFS is a fault tolerant. Okay, so why HFS is fault tolerant? We were discussing about when you upload some file into Google, so Google will make sure it's fault tolerant, right? So how it made sure that it is fault tolerant? Okay, Acha, tell me one thing. So have you guys gone through this document which I shared?
Yes, sir.
Okay, so RDD is fault tolerant. You mentioned that. How RDD became fault tolerant? I need that answer. So can anyone let me know where that is in the document? So where is that? You said you have gone through the document, right? So where is that fault tolerant? You guys able to see my screen, right?
Yes, sir. Yes, sir.
Okay, where is that fault tolerant here?
It's in the
Hmm.
this this PDF.
It's in. See, you mentioned right. RDD is a fundamental data structure. Okay, fundamental structure of Apache Spark. Till there, it's fine. Okay, fundamental data structure and immutable. Fine. Resilience. While speaking about resilience, we mentioned a fault tolerant, right? Okay. So how it became fault tolerance is I just wanted to know that answer. How it became. Just small example. How RDD became a fault tolerant. RDD is resilience. Resilient. Resilient means fault tolerant. That means in case in case any one of the executor will work on single partition, right? Let's say five executors will work on five single partitions. Let's say one executor unable to process that single partition, what Spark will do? Since you are not going through these concepts again, so same question I asked and you were able to answer in the previous call, but now you are not able to answer. See, any answers? It will relaunch that partition in the other executor,
When
right?
partition RDD is lost,
Okay, when it
Spark
lost,
they got legacy.
Spark will.
Spark will
Hmm.
Spark uses reverse. I
Sorry,
mean,
somehow I'm not able to hear you clearly. You guys able to hear Karthik clearly?
yes,
Sorry, I was unable to hear you. Hello, am I audible?
Yes, sir.
Yes, sir, you're
yes,
audible.
sir, yes, sir, yes,
Okay, okay, fine. So Spark will relaunch in the executor, right? Different
sir.
executor.
Recreate last part.
Recreate lost partition. Exactly. That's what I was
Um,
looking for. So this is how you need to map your understanding. Okay. So just try to ask questions yourself and see how that happens. Okay. We discussed a good example, right? So you are making. I gave you a task of 20 pizzas, and each one making four pizzas each. So one pizza got lost. You won't throw all the 19 pieces away, right? You will just consider that pizza again. Simple, right? So that's how this happens in the Spark side as well. That's how it became a resilient, right? So if you have a five partitions, one partition unable to process successfully, then Spark will relaunch this partition, this say, partition, reconstruct this lost partition in the new executor. Simple, right? So that's how it became a fault tolerant, resilient. It will never encourage the failures. In case one partition fails, it will immediately construct the lost data and relaunch into the different executor. So that's what we discussed, RDTs, right? And what happens if I apply a transformations on an RDD? What happens? Is it going to create new RDD or it's the same RDD? Come on.
Sir,
Okay. So what happens? Let's say I will take an RDD and apply transformations on top of that RTD. Is it going to create a new RTD or it will be the same RTD?
same RD.
Same RTD. Are you sure?
Ravi, sorry to interrupt.
Yeah,
Yes,
Actually,
yes.
yeah.
Ravi, am I audible?
Yeah, you're audible, Subhashri. Yeah.
Okay, so can we ask these people
Hmm.
to give one demo in the Hadoop and demo in the Spark, right?
Yeah.
So it will be good. Otherwise, what I observe that they are not going through the topics properly.
Yeah. Yeah, exactly. After the call, they're supposed to revise these concepts. Otherwise, definitely we
Yes,
will
yes.
forward.
Yes, you'll forget because these are the base concepts and you should be very, very clear on the topics.
Okay.
Right? Maybe these are theories, but it
Hmm.
is required. So what you can do, I'll ask all five people.
Hmm.
One day you will keep for the Hadoop. So just divide the section among yourselves
Hmm.
and just show the demo.
Okay. So what I was thinking, Subhash, is so
Yes.
not only Hadoop and Spark, till
Uh-huh.
from Monday to Friday we will continue with the classes. Saturday
Mm-hmm.
in the morning,
Okay.
if you can set up
Yes.
this demo, right?
Mm-hmm.
So
Yes, 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 yes. That
right?
will be okay. That
So
will be fine.
Saturday
You
they
can
should
start from the SQL and Pythons, right?
yes, SQL and Python we can start, but I think they
I
had to
think
start back. Yeah.
yes, but the first they need to inform about the Hadoop and Spark. After that, they can go to the Python, then SQL.
Hmm.
Okay.
Fine. Yeah. So each one need to prepare and come for the. I mean, you guys okay with Saturday in the morning? We will keep it demo. So if you have any work, just come up and just first 20 minutes you will do the demo and you can just log off. That's it.
Okay, okay.
Fine. Everyone okay,
You
right?
prepare your own
Uh,
PPT and
Yeah.
practice
For understanding, and we might
and do
ask
not use
questions.
any AI, right? When giving the demo, because we all are in the virtual environment, so you should
Yes.
not read from anywhere and speak. No, right? I request you people, so do not use the AI.
Yeah. Please try to do on your own, so then you will get more understanding of the concepts. Okay.
Okay, sir.
Okay, on
okay,
Saturday.
okay.
But please do not be absent for that call. Okay. So if you're absent, just let us know. In the next day, you're supposed to be. Whenever you in the next class, right, you're supposed to give the demo.
Yes.
Okay.
Okay, sir.
Okay. So hope everyone here, right? I think
Veda
if
is absent. We
hmm,
we can ask in the group.
yes, I will ask
And
him.
no excuse, nothing. Because it's
Yeah.
already 1 month and so many topics are covered and
Hmm.
you need to practice.
Yeah, if Spark is also done, then that's it. I'm going to start with the Spark execution as well. I'm planning that. So in
Mhm.
that way, you will aware of all the things that needed as a data engineer. Okay. Then we will start with one cloud, AWS. Okay. So then if AWS is also done, then you are a data engineer. You're supposed to go through all these concepts. Otherwise, you will never able to make it. So make it thoroughly because when I started learning these concepts, right, I need to go through this concept every day. Every day in the morning, I used to revise the concepts. In that way, you will remember these concepts. I need to refer different materials. I'm never convinced with a single material. If you're not convinced with my teaching, so you go with some other tutorial in the online, fine, absolutely fine. But just learn it. Go with different resources. You have different websites. Just see what does that website say. That in that way you will increase your knowledge. So always try to, for single concepts, always try to refer multiple resources. Then only you will get to understand. So that's why. So if you try to prepare for the demo, right, you might get so many questions. Okay, because you never gone through this. Seems like you never gone through these concepts after the class, right? So that's why you might face different questions, different confusions. Okay, then you try to research in the Google. Okay, if not, just ping in the group. I will be there to help you. Okay, so but try to be prepared for the Saturday's demo. Okay, Saturday at 9 p.m. But I need to check with Veda on this because Veda might go to work. Does anyone know that Veda work on Saturday or not? No. Okay,
I
fine.
don't know. Let me check with her once.
Okay, okay, fine, fine. Okay. Anyway, I will put in the group as well. Post in the group as well. But yeah, Saturday it will be good, right? So you guys, it's kind of a push for you, right? You definitely need to prepare.
Yes, yes, Will. It's
Okay.
good. Yeah.
Yes, sir.
Okay. Fine. Okay, that's it. So, Subhash, you have any other things, or can we start today's class?
No, 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 Ravi, you can start.
Okay, fine. Yeah. Now, yesterday we were discussing two concepts, right? I mean, so, okay. Before that, okay, transformations, right? We are talking about transformation. Yesterday we discussed, day before yesterday, two types of transformations. What are those transformations?
Narrow and wide.
Narrow and
Wait.
wider transformations. What's the difference between narrow and wider transformations?
Um,
In by narrow transformation, data will not shuffle between
Yes.
the partition,
Hmm.
and
Hmm.
in the wider transformation, data will shuffle between the partitions.
Shuffle. Yeah. So we discussed some examples, right? If I gave you some code, let's say some task, you do not need to discuss with your friends, right? That's what we discussed on that day. For narrow, you do not need to discuss with your friends, but for wider transformations, you need to discuss with your friends. Okay, you need to shuffle data among yourself. Then only you can create that output, right? So that's what narrow and wider transformations. Okay. Now, yesterday's class, we are talking about two concepts, right? What are those two concepts, at least? What was the class yesterday? What are we discussing yesterday?
Repartition one
Yes,
and coordinates.
Coalesce and
and
repartition.
coalesce and repartition. What does they do?
Coalesce, it reduce the task. We will
Decrease the
go.
number. Decrease the number of partitions.
Number of partition. Okay, okay.
Re- Repartition is increase the number of partitions.
Can repartition decrease number of partitions?
No,
No,
no.
No. Okay. You're saying no because yesterday we discussed till that point. Okay. But let's continue today's class. Okay. So repartition and coalesce, that's what we are discussing for the today's class. Okay. This is one of the very important concept. Okay. You might get this question in the interviews as well. Okay. So we discussed, right? Yesterday, let's say you have five partitions. Okay. Five partition, and each partition has two records, right? R1, R2, right? So now, let me quickly write this. Now I want you to answer this. How these things work after the repartition and college. Let me quickly put the data. R5 and R6, R7 and R8. Okay, R9 and R10. Okay. Now I'm going with college. Okay, it is visible, right? Okay, so college. Okay. Now college, right? Data frame dot collies of 4. That means here I have 4 partitions, right? How can I zoom this screen? Okay. Okay. So here Coles has I mean this has one, two, three, four, five partitions. Okay. Now always remember partition will start with 0. Okay. 0. Okay. Okay. So there are 5 partitions. Okay. Now I need to make into 4 partitions. What will happen here? Just let me know. Maybe you start confusing because of this. Okay. Perfect. Now let me know what happens here. Data frame dot collies of 4. I need to bring these 5 partitions into 4 partitions. What happens first? How how
And
how partitions repartition happen? Yeah.
so one partition will go to any other places. I mean,
Only one
D4 goes to
partition will go to.
another partitions.
Okay. Then what happens to the remaining? You
So
say out of 5 partition, only one partition data will get shuffled. And what about the other 4 partitions?
um, it's I mean
It's
store the that another partition.
store the same
Store the same partition for same repartitions.
same partition exactly. So these 4 partitions will come as it is. Okay, all as it is. This fifth partition, right? R9 and R10. These values needs to get shuffled. Okay, so that can go anywhere here. Let's say it goes to P1. Okay, let me put it here. R9, right? R9 is gone here. Now R10, right? R10 will go to some of the partition. Let's say it came here. R10, perfect. So your data got shuffled here from these 5 partitions. Okay. Now let's go and see how repartition happens. Okay. So now I need to understand how repartition happens. Again, data frame dot repartition of 4. Okay. How this will happen? Now what happens here? You mentioned collies.
Then
In case of collies, 4 partitions won't get changed. Only one partition's data will get distributed among themselves. Fine. Now what happens with the repartition?
sir, in repartition, the partitions is increased, right, sir?
It increases the
Increase, uh, increase the partitions.
no repartition can also do the can also reduce the number of partitions. That's what we discussed right yesterday. I told you some shuffling concept here. What's the difference between collies versus repartition? If you remember, that's why I always ask you to go
Shuffle
to
is
the
slower in repartition, sir.
sorry shuffle is
Slower in repartition.
slower in repartition. Why? Actually, what happens internally? So if you are able to answer that, then you will get the answer. What happens here? The moment I hit this repartition, that's it. How data will get shuffled? So 4 partitions, right? So does it take all these 4 partitions and again do the same thing like collies, or what it will do?
We take 5 partitions. After that,
Hmm.
shuffle the uh, four
Okay.
partitions.
Okay. So does it take 5 partitions or 5 partitions data?
Uh, 5 partitions data.
Data. Perfect. Okay. It will take entire data and it will shuffle entire data. That's what we discussed, right? So the difference between repartition and collies is the collies will take the partitions, will keep few of the partition as it is, and just that partition which he wanted to eliminate. So he will just shuffle that partitions data among these partitions. Okay, but in case of this repartition, right, what happens is it will take all the okay, it will take all the data, not data, we can say, let me take this. Okay, it will take, okay, think in this way, it will create some say empty partition. Okay, empty partition, it will create some empty partition. Okay, it will create some empty partition. Okay, it created four partitions. Now what it will do is it will do the entire data shuffle. So it won't go with the same data again. It might give some R2 and R3 here, R4 and R5 here, right? And again it will go here and it will give R10 and R9 here, right? So it will do the entire data partitioning here. That's what we discussed, right? R3 and R1. And here it will take what are missing? R6, R7, R8, right? See, it done all the repartition, right? All the data. It shuffled entire data, right? Where in case of Colis, it shuffled only this data, right? Right? It's simple. So the difference between Colis was repartition. If someone asks, okay, Colis will decrease number of partitions with minimum shuffle. Where in case of repartition, it will decrease number of partitions with come on, I need an answer here. Colis will reduce number of partitions with minimum shuffle. Okay. Repartition will decrease number of partitions with, come on. See, you need to be interactive here, otherwise you will never able to get anything. Come on. At least do say something, no problem. If you say incorrect, no problem. You will learn it. Come on. What are we doing here? Is it a full shuffle or minimum shuffle, or what kind of shuffle is this?
Full shuffle.
Full
Full
shuffle,
shuffle.
right?
Full shuffle.
So Colis will reduce number of partitions, okay, with minimum shuffle, right? So far clear?
Yes, sir.
Okay. Now repartition will decrease number of partitions with
Maximum shuffle.
full shuffle. Exactly, with
Full
full shuffle, full data shuffle. It's not being partial to any of the partitions. It's just doing entire shuffle, entire data. It took entire data and just doing entire shuffle, right? It's full shuffle. And we discussed, right, whenever this shuffling happens, data shuffling happens, it's a costly operation. Costly operation in the sense data needs to transfer from my laptop to your laptop and your laptop to another laptop, right? Data needs to shuffle. That's a costly operation, right? So this whenever someone asks you to reduce the number of partitions, which one will you opt? Colis or repartition? Which one will you opt?
College.
Why? Why
Right.
Colis?
Sir, performance will be good, sir.
Why performance will be good? You're almost there.
It's avoid shuffling.
It avoids shuffling. Exactly. It mostly avoids the shuffling. It will do the reduce the number of partitions with minimum shuffling, right?
Yes, sir.
But in case
Yes,
of repartition, it will do full data shuffle. So it's a
right.
bit costly operation, right?
Yes,
That's
sir.
why it will do with the less shuffle. That's why we always go with colis in order to reduce number of partitions. Okay, but no worry. So just be thorough with this concept. That's it. Once I start the practical classes, right? Um, that I will definitely plan practicals. I thought only internals will be good, Spark internals, but I will definitely start practicals. Okay, then you will get to know most of the things. Okay, I'll show you live how things happens in the background. Okay, then you will get to clear most of the things, most of your doubts. Okay, but before that you always need to be thorough with the concepts. Otherwise, if I say something in the practical class, you will start confusing. Okay, that's why be thorough with the class. That's it. Just be thorough with the concept. That's it. Practical class, I will take care of it. Okay, fine. Now you are understanding, right, what is repartition and what is colis. Okay, so now let me put it inch further. So what happens if I need only three partitions here? Colis, right? I'm doing colis. I want only three partitions. There are five partitions. What happens here? I wanted to hear an answer from you. Now there are five partitions. I wanted to colis to three partitions. What happens here?
We'll take three partitions.
Three partition. Okay, let me take some three
Uh,
partitions random. Okay, it's not up to us, right? It's random. So let me take some
yes.
three repartitions. Okay, let me take these three. Okay, fine. Now what happens?
No, another two
Another
partitions
two partitions. Hmm.
shuffled minimum.
This data gets shuffled, right?
Yes, yes.
Okay, now this R1 can go here, right?
Yes, sir.
R1 can go here and R2 can go here. R2 can go here, right? Similarly, this R9 and R10 go anywhere here, right? So that's how the
Yes.
shuffling happens in the case of coalesce. Perfect. So far clear with the coalesce. Good. Nice. Now let's go to repartition. Okay, repartition. What happens in the repartition if I want only three repartitions?
We take all data in partitions.
All data. Perfect. All data.
In
Hmm.
we create three partitions.
We
I
create three
mean,
partitions.
the data shuffle
Yeah.
to partition.
These three partitions.
Yes.
Okay. It will take three partitions. It will put data here. Perfect. Right. So far clear. Exactly. This is how repartition happens. Okay, reducing number of partitions. Okay, fine. Now I wanted to introduce one more concept here. Just increasing number of partitions. Okay. Now yesterday we discussed the same thing, right? Can coalesce increase the number of partitions? Can anyone let me know?
Police decrease the partitions.
Partition. Okay. Can it increase the partitions? Number of partitions?
No, it's,
No, no, you can say it loud. Okay, no. Coalesce will never increase the number of partitions. Okay, coalesce is only for decreasing the number of partitions. Then what is the other option I have to increase the number of partitions?
re
Repartition.
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 Exactly, repartition. Okay, let's say this is the data I have. Okay, let me copy this. I'll go here. Okay, now I wanted to increase this repartition. Okay, same concept. Data frame dot repartition of 6. Now these 5 partitions I need to make into 6. Okay, what do you think, like what happens? Just guess what happens here.
We take all data.
All data first. Okay,
And after we create six
6 partitions.
partitions,
Okay,
the data shuffle to six partitions divided.
shuffle to 6 partitions. Exactly, that's what happens here. Okay, it will take all the partitions. Okay, let me not do that. No, we'll take this again. Okay, okay, it will take this partition again and again. Okay, create 6 partitions. 6 partitions. Okay, 6 partitions. Now this entire data, right? This R1, R2, this entire data it will take and it will be reshuffled among all these partitions. Now you might think, okay, it's not the even it's tried to give the data shuffle. How it happens is like mostly it will try to do is R1 here, then R2 here, okay, then R3 here. Here, what is R3, R1, R2? Records. Okay, so it records. Now R4 here, sorry, R5 here, R6 here, okay, then R7 here. Try to do some equal distribution. Okay, it will try to do that. R8, then R9 here, R9, okay, then R10 here, right? Perfect. This is how it does. Okay, you have 6 partitions here, right? This is 1, this is 2, this is 0. We can call it as P0, P1, P2, P3, P4, P5. 6 partitions you have, and this is how data got shuffled. So it tried to keep do the some equal partition. Okay, so to try to put equal number of records into each partition. But yeah, till here it was able to do equal. But for these two, unlucky, they are unable to get their other partitions, second row records. Okay, so for clear, right? Repartition, coalesce, how this happens. Okay, all these things I hope you are clear now. So if someone asks you in tomorrow's class or something, you will be able to answer, right? Clear,
Yes,
right?
sir.
I need
Yes,
yes or
sir.
no at least. Yeah.
Yes, sir.
Okay, fine. So transformations, mapping, right? I hope you are practicing these things, right? Mapping and all. We created some good examples and we discussed about mapping, filter, and all these things, sample, and all these things. Filter, flat map also we discussed. In the flat map, right? Will structure get retained? Since you're not going through the classes again and again. So we discussed, right? I'm okay, fine. This is your assignment. Take this as an assignment. So let me know what is the difference between map versus flat map. So I will pick any one of you and ask this question. What is map? What is flat map? Okay. Let me know the difference in the tomorrow's class. Okay. So now wider transformations we discussed, right? Wider transformation data shuffling will happen. Okay. So join. We discussed about the join, right? On that day with some good example join. And coalesce and repartition we discussed. Right? Yet now we just discussed
Yes, sir.
coalesce and repartition. Okay.
Yes, sir. Yes.
So now let me know, coalesce and repartition belongs to wider transformation. That's what this document says. Why they belongs to wider transformations? Why these two belongs to wider transformations?
It's a full drive.
Exactly. Data shuffle happens, right? We saw that, right? How data got shuffled. So if data shuffle happens, that means it's a wider transformation. That's it. If no data shuffle, it's an arrow transformations. Okay. So in production, right, when we start coding, right, if I start coding, I will try to avoid wider transformation as much as possible. Okay. But it won't happen. We definitely go with the wider transformations in the real time. Otherwise, you will never be able to compute the data. Compute means calculate the data, do some processing on top of the data. Okay. Yeah. So for fine, right? Fine. Now we came to the section action. Okay. So this action is very, very important. Why? Why action is very important in Spark? Come on.
Non-RTD values.
Non-RDD values. Okay. That's what document says. But I want what you understand. So what does this actions? Why actions are very important in Spark? Everything is important in Spark. I'm sure. But why action is very much important? Because we discussed some law, some rule with the Spark, right? No, no answer. Okay. Let me know what is lazy evolution.
Yeah, Spark is a lazy evolution. For that,
Hmm.
without action, Spark won't do the transformation.
Transformation. Exactly. Then,
Yeah.
then action is very important, right? Right? Because you write your entire code, but the code do not have any action. That means Spark won't do anything unless until it sees action. It won't start anything. Then action is very, very important. Okay. So that's why this action is most important thing. Okay. You need to understand what are the actions, and also action side, right? You need to understand few things, right? Action means uh, you need to display your so you will create some transformation, right? Transformations, what you will do. Let's say I gave you books, right? The example we discussed, right? I gave you books. Okay. So those books, I will give you 5 books each. Okay. Five, 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 five. You calculated. Okay. Sir, you gave me 5 books. Everyone says that. Sir, you gave me 5 books. Okay. Total, how many number of books are there? 5 into 5, 25 books. I distributed 25 books among yourself. Okay. Now you calculated those 25 and just saying that, sir, you gave 25 books. We distributed 25 books among ourselves, right? So those 25, right? 25, either I need to show it to me, or you need to store it somewhere, right? Either you will store it some location or you need to display it to me, right? That's what we will do. So there are two things here. So action, right? It will try to display the results either to the user or just store these results in the some location. Okay. So that next time if someone who needs that results, right, they can come and use this thing. Okay. So that's what this action will do. Okay. Okay. And first thing, action will trigger the execution of the transformation. Okay. Then this all calculations and all will happen, transformations will happen. The moment the action is triggered, Spark will read data from the source. Okay. Source, first point. Then Spark will divide that into partitions, second point. And third, these partitions will be assigned to executors. Okay, now executors will have the recipe in the sense code. Okay, the code they will try to apply on top of this partition. Okay, once that is done, the results, right, the results will be passed back to the driver. Okay, now driver will decide based on the input we gave, right? It will display to us, or it will try to post it to the, store it to the some location, S3 location, HDFS location. It could be anywhere. Okay, so that's what this made action will made Spark to do. Okay, now let's go this one by one. Action in Apache Spark are operations that provide non-RDD values, right? Non-RDD. So we know, right, like transformations and all, we it's an RDD, resilient data structure. Okay. So what it do is it will take the data, it will make it immutable, it will reconstruct the data in case it lost, all this kind of stuff. But in case of action, we do not have such features here, non-RDD. We do not have this resilient data distributed data set. Okay, now they return the final value to the driver program or write to an external system. That's what we're discussing, right? Either you will display the final value, okay, or write value to the external system. External system is storage system. Okay, it could be storage system S3, HDFS, your Windows Explorer, it could be anywhere, but it's a storage system, it's external to that Spark. Okay, and sometimes it will return a value to the driver program. Now driver program, why driver program will need these values is it needs to showcase or display these values to the user. Okay, they will return a final value to the driver program or write data to an external system, external storage system, you can just remember. Okay, now if someone asks you what is action, you say first point you will say is not this. First point you will say is Spark is a lazy evolution, hence without any action Spark won't execute any transformation. First thing. Okay, and second thing, actions in Spark provide non-RDD values. Okay, they return the final value, and that final value will be given to the driver program for showcasing, or it will be written into some external storage system. Okay, if someone asks, just explain this lazy evolution point. If someone asks in interview, right, just explain this. Because of lazy evolution, you are doing you need action. Okay, then this final result, right, you got that result will be either given to the driver program or written into the external system. Just try to update this. Okay, now action trigger the execution of the transformation operations which we discussed now, accumulated in the direct acyclic graph. Okay, so what is direct acyclic graph? What is direct acyclic graph? We discussed this concept. Directed acyclic graph. Anyone? We discussed this concept. I'll show you the emails. Let me know how. Yeah,
DAG is a
DAG is a fundamental
fundamental concept. Represents logical something,
logical
logical execution.
logical execution. Okay. Okay. By seeing this,
Nodes and edges is there.
nodes and edges are there. Perfect. Okay. So what is this nodes and edges here? 1, 2, 3, 4, 5. We discussed something by showing this same example. Same example we discussed.
SR, SR.
So what is this nodes and edges here? What happens actually? What is this one?
No,
Node.
Okay, one is a node. Okay,
passes to 2
passes to two. Okay,
and 3,
and three. Okay,
but it will not pass to 1,
back,
4 and 5,
back.
1.
Okay, what that is called? What that concept is called?
Cycle.
Cycle, acyclic. Okay, acyclic. That means it can go in only one direction. It cannot come back. Okay,
Yes,
not directly from 2 to 1. It cannot, not only 2 to 1, not other, also from 2 it went to 4, right? From 4 also it cannot come back to 1.
1.
Okay, not cyclic. It cannot go back to two directly, one directly. Two cannot go back to one directly. Indirectly also it cannot go back. Indirectly it cannot call four. It will go to four. But four can come back to one. That's what people will think. No, because this two, if four come back to one, then it becomes a cyclic, right? So it won't happen. Okay, so that's what acyclic means. Okay, perfect. So that's what acyclic, and this is a graph, right? Nodes and edges, anything, any diagram you see with nodes and edges, you can consider that as a graph. Okay, nodes and edges. And directed, why it's directed? Because it's single direction, right? It has only one direction, from here to here, that's it. Do not have any direction, right? Only one direction. In one direction it will flow, right? It won't need to go into multiple directions. So that's why it says direct acyclic graph. Okay, fine. You understand what is direct acyclic graph? Okay, directed, it's directed in one direction. Okay, acyclic, it will never go back to its previous node, right? Okay, and it's a graph with nodes and edges. Okay, so far clear. What is DAG, you are aware. Now now why this DAG came here, DAG concept came here, is because why this tag concept came here is, we discussed, right, Spark, right? The moment it took the data, again let's go with the pizza example only. The moment you got the ingredients, okay, you will take maida first and water, and you will mix a solution, right? Then you will move to the next stage. You will prepare some chapati kind of stuff or something, you will move to the second stage. And next, actually we need to refer to step one, step two, but I'm mentioning stages because in Spark we will go with the stages only. Stages, tasks, and jobs. These are the key terminologies you need to be aware of. Okay, stages. Okay, so first stage, you will perform something. Okay, it could be anything. Let's say you wanted to. Let's go with some good example steps. Preparation. Okay, let's go with any example which has some good steps. Okay, let's say you wanted to download any, you wanted to do phone pay transactions. Okay, phone pay transactions. What you will do is, you will open an app. Step one, right? Step one, you will open the app. Okay, step two, step two, you will authenticate yourself, right? The moment you open an app, you need to enter some password, or you need to enable, you need to give your fingerprint. Step two, right? Then you have two operations, either to check the balance or to transfer the balance, right? Two separate operations. So if you go here, then you might come here and do it or something. But yeah, it's a two different operations, right? Like, you can think of steps. It's not the, maybe not the good example, but yeah, you can think of steps. Step one, sorry, stages. Stage one, you will open an app. Stage two, you will do, you will authenticate yourself. Stage three, you will inquire your balance, or you will send the money. Okay, so these are the steps involved here. Three steps, very simple, three steps. Okay, similarly in case of Spark, right, the moment it read the data, it will prepare some plan, right? You will give some code to Spark to execute. So Spark won't directly execute that code blindly. Okay, Spark internally perform some optimizations for your information. Let's say, if you take the code as is, I'm not a good coder. Okay, if I write a code and give the code of Spark as is, then if Spark runs that code, then it's very bad code. I written that bad code. Okay, now if Spark tries to execute this code, okay, now it will cost us, right? It will do all data shuffling. In place of Colis, I use repartition, which is very bad, right? So this repartition will cause full data shuffle. That means it's a costly operation. That means data needs to shuffle entire the data. Let's think, like we just discussed, only 10 rows here in this example, right? Only 10 rows. What if you have some lakhs of records? Okay, that's a very bad thing, right? Like, you are shuffling lakhs of records among these nodes. Okay, among these executors, you're shuffling hundreds of lakhs of records, which is definitely not good, right? But however you write the code, spark will take that code. Okay, take that code. It won't do the execution as it is. No, Spark has some plan. These developers, right, they're very good. So they already given some by default rules to Spark. Okay, so Spark will construct this tag. this DAG on top of those rules. Okay, so you will get to know more details when I dive deep into this concepts. Okay, DAG and all. But yeah, Spark will have some rules. Okay, so based on top of that rules, Spark will start executing the data. Okay, so the rules are already predefined to Spark. Okay, based on that, the Spark will try to create a DAG. DAG means what is the first step it needs to do, first stage it needs to do. Next, what is the second stage, what is the third stage, what is the fourth stage. It will prepare stage by stage plan. Okay, because it knows the rules. What is the first, like you gave some. Okay, so you gave, let's say, first check the balance, that's it. But before checking the balance, you need to open the app and you need to authenticate yourself, right? Spark will aware of those things. Spark will do, the moment you say check balance, it will go and see. It will never do directly try to do check balance. No, it will try to, authenticate first, and then it will try to open the app, authenticate, and then check the balance. It will follow that approach. Even though you miss it, Spark won't miss it. It has some rules defined, pre-defined rules. It needs to act in that way only. Okay, so that's where this tag came here, right? So DAG is a direct acyclic graph, directed acyclic graph. Okay, so that's how this tag concept was introduced here. But do not worry, so I'm going to show you how tag is prepared with some good code. Okay, so it has that. Yeah, so this is tag. Okay, so all these things you will definitely see, but yeah, for now just remember those things. Okay, I think I gave code as well. Yeah, this is the code, sample code. So I will show you how these things happens. Okay, how DAG is created here, all these things, stage 1, stage 2, stage 3, how this tag, entire tag will show. Okay, perfect. Let's go back to our action concepts. Okay, this is actions. Perfect. Now collect. Let's see, collect is an action. Okay, by the way, so here are some commonly used actions in Spark. Okay, collect. Collect is an action. Okay, what collect will do is collect returns all elements of the RDD as an array to the driver program. Okay, so if you do data frame dot collect, it will take all the values and return it as an array to the driver program. Okay, perfect. Now, this can be useful for testing and debugging, but be careful with large datasets to avoid out of memory errors. Perfect. So what it says is, the moment you do collect, collect means collection. You know, right? The collect word itself says that collection. I have some good collection of cars. I have some good collection of mobiles, right? It's a collection of data. Okay. So the moment you say collection, it will trigger in transformations. All the transformations will executed, and finally this data, the output data, will be collected as an array and given to the driver. Okay, driver. Now driver will take this data and display it to us, or it might be used for testing and debugging as well. Testing in a sense, okay, how you done some transformations on top of the data. You need to see how exactly the data is transformed. On the day we discussed, right, first name last name should be converted to full name, single name. Ravi is a single in single column. Teja is in single column. I need to combine it and make a Ravi Teja in single column. Right? We discussed that. And how is it working fine or not? How you can test it? You can test it via this collect or show. Okay, we have that show as well. Maybe here not there, but yeah, you can test it via show as well. See, collect is a very costly operation. I mean, not costly, I can say. Collect is very dangerous operation. We will never do this collect in the real time production. Why? Because let's say it's going to return this elements of an RDD as an array to the driver program, right? It's going to return these elements of RDD as an array to the driver program. Perfect. But these elements, right? Driver is also an executor. Driver is also a mission. Let's say it mission with 2 GB RAM. Okay. If you return these elements to driver, okay, driver memory is 2 GB, but you are returning 10 GB of data to the driver. What happens? It will fail. It will encounter out of memory error, right? You need to collect the data to the driver. So the moment you trigger a collect, it's going to put your data into the driver. Perfect. Now driver needs to have that capacity to incorporate all this data into its own system. Let's say my laptop, right? My laptop's memory is 256 GB. Okay, in this, out of this 256 GB, we discussed about a container, right, in HDFS, right, and all resource manager. Out of this 256 GB, 2 GB RAM and 10 GB memory, okay, is will be a container, and in that container driver program will get launched. Perfect. Driver program got launched. Now here in this 2 GB I need to incorporate entire 10 GB of the data. It can't be happen. It's not possible. My driver program will throw an error because you cannot incorporate this entire data into the driver, right? Because driver has to maintain many other programs. I mean, many other task stages and all, right? So you can never able to incorporate all this 10 GB of data into 2 GB of a driver. Okay, if you have 10 GB of a driver, then it's okay for you. But if it's 2 GB, we can never do that. So that's why you never know. So right, that's why we will never encourage collect in the production environments. Okay, so for clear, I believe. Okay, now count. Count returns number of elements in the RDT. This we already aware, right? So count, right? I gave you the task to count number of books. You know how to count and all, right? Now first returns the first elements of the RDT. It's also kind of collect, okay? But in case of collect, it will collect entire data, okay? What if I do not want to collect entire data? I want to collect just first 10 rows. Then I can take this can take this first. Sorry, not first. Let's say this will take only the first element of the RTD. That means you have some lakhs of rows, but if you use the word first, it will take only the first element, I mean first row of that table. Okay, take. Take means take of n. That means take of any number you give, just 10 you give. That means it will take first 10 records from that table and it will give it to you. Okay, so that's what take will do. Okay, so take is also an action. It will perform. It will extract only first n elements of the RTD. Perfect. Now for each, okay, for each is used for performing computations on each element of the RDD. I mean, it's always self-explanatory, right? For each, for each, for each object in the list, okay, for each element in the list. Similarly, for each element in the RDD, for each, okay, for each element in the that RDD or that list, whatever it is. Now, save as text file. Save as text file means writes the elements of the dataset to a text file or set of text files in a specified directory in the local file system, HDFS, or any other Hadoop supported file system. Okay, save as text file. We discussed, right? Either this output will be passed to output will be final return value to the um, driver program or write to a data to external system, right? These collect, count, first, take, for each, right? These mostly return data to the driver. Okay, now this save as text file, save as sequence file will return this data to the external storage location. Okay, so for clear, so what actions will do is either it will return data to the driver program or external store the data into external storage system. And these are the driver operations. I mean, this data is written to driver and this data is written to the some external storage system. Okay, so that's how actions. See, this is the entire flow. You will create an RDD. Create automatically the moment you load the data, it will create an RDD. Okay, you will do transformations on top of this RDD. I mean, the moment action is called, you will do transformations. You already written transformations, but the moment action is called, the transformations will get triggered on top of these RDDs, and that result will be given because action is triggered because you wanted to have a result. Right? The result. Perfect. Right. So this is how this actions and transformations looks like. Okay. Yeah. I think my charging power is running out. Just give me a second. Fine. Um, the task is for tomorrow's class is map versus flat map. Okay. Please go through this map and flat map concept, and I might ask you any one of you to explain what is map, what is flat map. Okay. That's it. So for any doubts in the class, anything with the other classes, any doubts, you can post it now. Stop sharing my screen. Yeah. Any doubts? Anything?
No, no doubts. Class.
No. DC, Anushka, any other doubts? Okay. You mean no doubts? Fine. But hope you guys are going to revise these concepts again today. Okay, but be prepared. On Friday we will have the class in the morning. Okay, 9 a.m. mostly, and on that day you need to start demo on. We will go concept wise. Okay, HDFS, MapReduce, and YARN. Those are three concepts in the Hadoop, right? We discussed, and then Spark. Okay, let's start with HDFS. Okay, HDFS, MapReduce, and YARN. Okay, so you need to pick these three concepts and try to come with some PPTs, documentation, how you want it to come. Just come, and I do not want to see some chat GPT answers there. Okay, don't try to prepare. Try to write it in your own words. Literally, I wanted to see grammatical mistakes in those things. Okay, so then only I can understand. Okay, you done some. It was written on your phone. Okay, so then you will get easy. Okay, then you guys will start giving demo, and me and Subhashri might ask some questions in that demo. You need to be able to answer those questions. Okay, please do not skip those classes, those kind of sessions. Okay, it will be helpful for you only. Okay, that's it. In case you no doubts, we can wind up.
Sir, tomorrow class morning.
Tomorrow class will be morning, as we discussed earlier in the group, right? So everyone okay with that, right? I think you guys voted there. Okay,
Yes,
fine.
yes.
9 o'clock, and tomorrow we are going to cover both Wednesday's class and Thursday's class. Okay?
Okay, sir. Sure.
So Thursday you guys can take off.
Okay, sir. Sure.
Okay, fine.
Yes, sir.
Okay. Thank you all.
Thank you,
Bye.
sir. Thank you.
Okay.
Yes.
Thank you.
Thank you so much.
Thank you.